Hello, everyone. I would like to welcome you all to this webinar. Since the onset of the crisis, the inability of the Lebanese government to finance power production has led to dramatic shortages in power supply, especially as energy prices increase at an unprecedented rate. This pitch dark reality of our power production capacity has led many Lebanese to rush towards the installation of solar power systems or photovoltaic systems as a cheap, reliable, and clean source of energy. But how clean is PV technology? While most certainly PV systems are a cleaner source of energy in terms of emissions, they nevertheless pose a greater challenge in terms of waste management once they reach the end of their life. Today, we will discuss the long-term challenges of solar power systems, and more particularly, how we can achieve an environmentally sound end-of-life management of such systems. To that end, we will be exploring how such waste management practices could encourage the recycling and repurposing of some of PV power systems' essential components, taking into consideration Lebanon's recycling expertise. Before I initiate the discussion and introduce our first speakers, allow me first to introduce myself. My name is Ali Taha. I'm a researcher here at the Lebanese Center for Policy Studies. And my research focuses on areas such as public policy, governance, and energy. I hold a BA in political science from the Lebanese American University and a master's degree in international relations, specializing in energy politics from the University of Amsterdam, and I will be the moderator of today's discussion. I would like to also notify you that simultaneous interpretation is available. You can activate it by pressing on the translation button in the bottom of the screen. ألفت انتباهكم بأنه باستطاعتكم تشغيل خاصية الترجمة الفورية من الإنجليزية إلى العربية من خلال الضغط على الزر المشغل أسفل الشاشة. Our discussion with the speakers will last for 45 minutes, followed by 10 minutes of Q&A. Questions can be submitted in written form in the chat box at the bottom right corner of the screen. Unless specified, I will choose the speaker to whom I will address the question. This webinar will be live streamed on both the IFI and the LCPS Facebook pages, and a recorded version of this webinar will be available on LCPS website and Facebook page. Finally, today's webinar wouldn't have been possible without the joint effort of both my colleagues at the AUB Aysam Faris Institute of Public Policy and International Affairs, and especially to Mark Ayoub, as well as my colleagues here at LCPS. So I would like to thank all of you. I would like to also thank the Dutch Embassy that is a supporter of LCPS and of this particular event. Moreover, I thank our dear speakers who have been keen on sharing their knowledge with the wider public and whom I'm going to introduce before each intervention. So let's start our discussion with Mark Ayoub. Mark, allow me to introduce you first. So Mark is a postgraduate energy researcher at the University of Limerick in Ireland and an associate fellow at the AUB Aysam Faris Institute of Public Policy and International Affairs. Since he joined IFI in 2018, Mark was part of a team that has worked on producing energy mix scenarios in Lebanon and the MENA region, mapping of available public lands and conducting techno-economic assessments of renewable energy projects, including that of a 300 megawatt solar power plant in the Tfail region. He also worked on mapping the potential of decentralized energy systems in Lebanon and assessing their replicability. Mark holds a master's in chemical engineering from the University of Balamand and a Bachelor of Science in Chemistry from the Lebanese University. So Mark, could you explain to us what are the types of PV technologies being used in Lebanon? The floor is yours.
Thank you so much, Ali, and thank you for the LCPS team for the collaboration on this. Thank you, Nisreen and Eli, also for your to agree to be with us on this webinar. And I hope this is like a first step into future work between both institutions, and hopefully something bigger soon. I'm gonna share my slides just to introduce a bit the topic from the policy component, and hopefully when also Nisreen and Eli will talk about their project, their presentations, we will be able also to understand more in depth. So just a second to be able to share the slides. All right, this is it. All right, so we're talking today about the long-term challenges of solar power systems and managing the panel and battery end of life. And actually, this is the reason or the rationale behind this webinar was really, of course, a lot of people now will say, or a lot of the attendees and the people hearing us will say, why are you talking about something that, or a problem that is not really there, or it's not really a priority, and there are a lot of pressing issues on the electricity side that are more important to tackle. But actually, what we are trying to do today is try to shed the light on a problem that we see in the coming years, and we think that it needs a lot of preparation and work in terms of policies, in terms of laws, decisions, etc., from early on, because what has been happening over the past year or so is really an indicator that things could go wrong, and we have to be ready when this happens. So I'll try just to, as a start, to put things into context before diving into the details and technicalities. Just talking about the renewable energy landscape in Lebanon. So of course, most of us know, or the majority of us know, that there's still no legal framework for the development of renewable energies in Lebanon. But everything that's happening really is based on decisions or top-up approach on existing policies. The crisis has really pushed the topic of solar kits or solar PV plus batteries to the forefront. People have realized the importance of renewable energy during the crisis, and starting early 2021 and even a bit earlier when the electricity cutoffs started increasing from EDL, and this is when they diverted or went into solar systems. So the landscape of renewable energy, we had previously, over the past decade, we had only one decision taken by the EDL board, which is the Circular 32-318, which established the net metering process for people having solar power systems and allows them to sell their surplus in exchange to credit and bills, so have an exchange of electricity with the national grid. In terms of electricity laws, and I'm talking about legal framework, we know that the only, or the umbrella law, or the umbrella framework for the electricity in Lebanon is Law 462. But over the years, this law has never been implemented, and we had other like modifications or ratifications to this law. Mainly, I'm talking about the 775 over 2006, 288 2014, and 54 2015, and even 129 over 2019, which amended partially the Council of through the 462 law, and allowed the Council of Ministers to give licenses for the independent power producers. And this has been renewed over the years until recently, until the law 129 went out of the deadline in April 2022. Recently, and this is something to note for the ones who don't know, recently the Council of Ministers has approved 2 draft laws that have been in the making over the past 3 years. And I'm talking here about the Distributed Renewable Energy Law and the Energy Efficiency Law. Those still need to be ratified in the Parliament, but when done, this will allow, or this is a breakthrough in the legal framework, and will allow individuals, municipalities, and even commercial players to produce electricity and distribute electricity and sell electricity private to private, and even to the grid. So the 2 updated policy papers of 2019 and the recent one of 2022 have a lot of plans for renewable energy in Lebanon. The one of 2019 has mentioned around 840 megawatts of solar PV plants and 600 megawatts of wind The 2022 electricity reform plan mentioned something around 1.1 gigawatts of solar and wind projects, some of which were listed in the 2019. But both plans confirmed that the target of Lebanon is to reach 30% renewable energy by 2030, and which is total energy total consumed energy. And this is from where we see the problem and some of the problem. If those numbers are really implemented, this is where we enter into the topic of today's discussion. So the installed capacity in Lebanon has been to some extent minimal over the past decade. So the 2019 numbers of the Lebanese Center of Energy Conservation show 78.65 megawatts of distributed renewable energy across the country. Now, this was in 2019. In 2020, this number has increased to reach 89 megawatts. The current unofficial, let's say, numbers from the LCEC expect an additional 100 megawatts only in 2021, and this is because of the crisis. So what we have installed over the past decade between 2010 and 2020, we installed in 2021, or the numbers show that we almost installed the same number because of the crisis, and this shows how much demand is on solar systems. In terms of two decrees when it comes, or decisions, and here they were mentioned in this slide, we have the decree 6887/2020 by, we have ERI and the Ministry of Industry also, which is under the Ministry of Industry, Circular 006/2021. And those are two decisions, not really laws. Those are decrees and the circulars that tackle the issue of systems, of solar photovoltaic systems. So the decree sets the standards for those systems, and the circular, the ERI circular, does not allow used and damaged solar panels to be imported as of October 20, as of the date of its publication. So recently, because of this increase in numbers in terms of renewable energy installation, the Ministry of Energy with the LCEC and the Ministry of Interior and the municipalities in October 2021 have developed or shared a new policy for rooftop solar PV to ensure the system safety. And this policy, let's say, or a new process or procedure is for the installation of rooftop for the metallic structure that to be installed on the rooftop of buildings, just to ensure that the safety of the system is there. What are we talking about when we install solar kits currently? So people who are installing such systems, of course, we have some electrical wires and everything on top of those, but we are talking about three main components. The solar panel, the lifetime of which is expected to be sometime between 10 and 15 years. We have the inverter, which is considered as the most critical piece of link between the energy storage systems and the grid. And we have the battery bank, or a series of batteries. And here we are talking about two types of batteries currently being installed in the local market, in the Lebanese market. We are talking about lead acid batteries, the lifetime of which is between, and this depends on the cycles or number of cycles the battery are operated, between 3 to 4 years. But we have also the lithium ion batteries, which are a bit more expensive, but the lifetime is higher and ranges between 10 and 12 years. So we have those components, but really what's the problem? What we have been facing as problems in the past year. So first is the quality and compatibility of installed products and systems. So everyone, and you might hear that in your communities, have been complaining of some products, be it the solar panel or the inverter or the battery, that are the quality of which are not really according to the standards. So once the quality of those components are not really compatible, this will cause default of the system in shorter times. So we might have a default of the battery in less than 3 years, for example. Also, we have the batteries, and the batteries include some hazardous materials. I'm talking depending on the type and the chemistry of the battery. We're talking about lead, cobalt, nickel, lithium, and those cannot be treated same as we treat the normal waste. And here I will leave the details for Eli and Nisreen to talk about it, but these cannot be dumped. A third core problem is the non-conformity of systems, of those systems, especially in batteries. And because the inverter or the panel with the battery is not really compatible, sometimes do not work compatibly, they might cause security concerns in terms of fire and others. This is where appropriate policies, appropriate policies should be put in place. Arrangement for the safe disposal and recycling of end-life management of batteries are really vital at the very early stage. So the main question is this: how this equipment will be handled and who will be responsible for their end-of-life management within the Lebanese case study. As I mentioned, there are only those two, the decree and the circular, which are really talking about this topic, but nothing about the batteries. So if we go into the value chain of the components, I could mention, and very briefly, we can talk about the value chain or the life cycle of the components. We talk about first the installation, its safety, the performance of it. It should be performing very well once it is securely and safely installed. And at the end of its life, we need to talk about the recycling, its transport, and also training on how to recycle. And this should be according to international norms and international engagement. So if we dissociate the two components, which are the panel and the battery, so for the panel, of course, most of the technologies currently is the crystalline, monocrystalline or polycrystalline silicon panels, and they are in most of the markets. So this component or this panel includes aluminum, it has glass, it has copper and polymers and the backsheet, and in addition to the solar cells that constitute the panel. And many of these need to be recycled, cannot be like thrown away directly. If there is no recycling for the system, and if we just calculate the CO2 emissions from the manufacturing of those panels, if we don't recycle them, then they will emit more CO2 emissions from the time we will be using them to reduce the CO2 emissions from fossil fuels. So this is an important issue, as we estimate 60 million tons of solar PV waste by 2050. And even if currently this recycling is not really economically viable, and this is why countries and companies are trying to get rid of those without being recycling, this should be the future when the market grows exponentially. So when we talk about the battery, and this is the main problem here, we have currently, and I'm talking about the current Lebanese case, we still have lack of policy or regulations when it comes to recycling. So we don't really know what we will be doing with those batteries currently installed in 2021, 2022, in 3 years' time, for example, once the life ends. We see a lot of gaps and uncertainties about the installation standards. So we don't know if the standards are being followed when it comes to installing and labeling those systems. So here the role in standardization for battery systems are to be supported, and also the product safety. So it is essential for the suppliers supplying these components in the Lebanese market to ensure safety and not to have safety problems in the future. So I just tried in this slide to put a mapping of, this is not really inclusive, but could involve a lot of supporting actors to this. As I said, while it will be some time before these batteries enter the waste stream in large numbers, the ground would need to be done ahead in time to ensure that all environmental and safety risks are managed. And here a big role should be for the ministries at the level of ministries. First, the Ministry of Energy and Water, the Ministry of Environment, and the Ministry of Industry, and the supporting institutions or organizations under these ministries, mainly the Lebanese Center of Energy Conservation, the ERI Institution of Research, Industrial Research Institute, and the LIBNOR, to set the standards. And this is something they have been doing for other components or other things, for example, meters for diesel generators or other things. And they are capable of start to work on those policies or those regulations and standardizations when it comes to batteries and panels. So just not to take too much time on this, here are my main thoughts and recommendations on the policy scheme, some of which need to start very, very soon, not to have to avoid any problem in the future. So, and this will help support Lebanon play a greater role in repurposing and recycling used batteries. So first of all, policies and practices related to the recovery of batteries should be developed. Rules and guidelines for panel batteries should be put in place by the identified stakeholders I've mentioned. And we need to prepare some Lebanese standards for the installation, safety, performance, and recycling of batteries, and to ensure that all the stakeholders I mean here the governance, the institutions, the companies that are installing, and also the consumers have information on the recycling, so awareness campaigns for consumers as well. For the existing batteries, explore the feasibility of putting some tracking for those batteries after reaching their end of life. And we need to give some incentives for the consumers to do some recycling and promote life cycle assessment, and also think, and here I leave it also to the expert Nisreen and Eli to talk about it, so to recycling battery facilities, because I'm not sure if those facilities are existing in Lebanon or not yet, and who is handling this, but also, and last but foremost, the labeling for batteries, so we need to know this battery, which chemistry it is using, its security considerations, and that those security or safety considerations are done according to international norms. So this is just a quick overview of the needed things, and I'm happy to answer any question later on during the discussion, if any. Thank you so much.
Thanks a lot, Mark. Indeed, very important recommendations. And I guess you've answered the two questions, the one as well with regards to the regulatory framework. Thus, I'm going to move to Nisreen, and we're going to be looking into the type of waste generated by PV technology. But first, Nisreen, allow me to introduce you to our audience. So Nisreen Hujairi, Nisreen holds a bachelor's and master's degree in environmental technologies with almost 25 years of professional experience in overseeing and delivering a large portfolio of environmental projects in the GCC and the MENA region. Her areas of expertise include environmental planning and permitting, solid waste strategic planning, design and management, sustainability solutions, air quality control and management, environmental auditing and monitoring. Currently, she is the Director of Environmental and Sustainability Services at LASECO. She is also a founding member and the Vice President of the International Solid Waste Association, Lebanon's chapter. So Nisreen, what kind of waste is generated by the different components of the PV power systems, and how hazardous is it?
Thank you so much, Ali. I would like first to thank you in person, to thank Mark, the EUB, the Lebanese Center for Policy Studies for organizing this event. And thank you for having me on this platform. And I really look forward to the discussion session. I have prepared a few slides just to take you through what are the types of waste, the type of waste that is generated from the key components of a PV system. Let me start. Can you see my screen? Can you see my screen?
Yes,
we can.
Okay, yeah. Perfect. So what I've done is preparing a few slides. I'm going to have a brief introductory session, and then we're going to look at the anatomy and waste classification of the main components of a PV system, what challenges are facing the recycling industry, and concluding remarks on the key aspects that one should consider when we talk about a sustainable approach of managing the end-of-life solutions of this type of products. So to start with, we all know that, as you can see in here, the deployment of PV technology in the world is growing drastically. As you can see, since the year 2000, the amount of solar panels being installed in the world has been growing exponentially. And this is expected to continue to do so because it's a clean source of energy. And the situation in Lebanon, as Mark said, is even moving at a faster pace, because in Lebanon, we're seeing this as a solution for the lack of any source of energy in the country. And it is affordable, and it is technically feasible in Lebanon, a country where we have almost 300 days of sun throughout the whole year. So from a technical point of view, this is really feasible. To put things into the right perspective, let's have a quick look of what a typical PV system includes in terms of components. So we're talking about the solar panel, the inverter, the batteries, in addition to other devices, control devices, and cables. In this presentation, I'm focusing on two components, which are the main components in terms of weight and contribution to waste quantities, which are the solar panels and the batteries. So let's first look at how long do these components live before the need to discard them. So as you can see in here, the lifespan of the panels varies depending on the quality of the materials. And it can vary from, as Mark said, 3 to 4 years or 5 years to more than 25 years. And when we say cheap panels, this type of panel usually has low quality of silicon. It has less UV stabilized backing sheets, cheaper sealants, cheaper framing, etc. And this type of panels usually, it deteriorates very quickly when it is exposed to the conditions in the environment, atmospheric conditions like the weather conditions like the wind, the sun, the fluctuating temperature, the rain, etc. So they produce with time less electricity, and at some point in time, we need to replace them to maintain the same power production pace. For the battery, we're talking about mainly 2 types of batteries with a range of lifespan varying between 4 to 5 years to up to 10 years. And this can be even lower depending on how you're using your battery, because the mechanism of using your battery, how much you're using the energy of it, the stored energy of it, can make the lifespan of that battery less. So it has specific requirements on how to operate it to make sure that it lives to this lifespan. So, and as you can see in here, the more solar panels are produced, the more waste we're expecting in the future, and the quantity of waste is increasing in 2050 by a significantly, because by that time, the lifespan of most of the solar panels that were installed before would reach their end. So at some point in time in the world, we're expecting a huge quantity and huge flow of this waste. And this is a problem not only in Lebanon, it's a problem worldwide. And it's something that most researchers are focusing on at the moment. So let's start first by looking at the solar panels in terms of, to be able to say whether they are hazardous or not, we need to look at their anatomy first and to define what are they composed of. So there are different types of solar panels in the market. And in terms of their market share, we can say that the silicon-based panels, as you can see in here, they almost contribute to 95% of the market. They are the bulk, the main type of solar panels that is being installed and used. And there is 5% of the panels are the type we call thin-based solar panels. So let's look first at the first one, which is the silicon module. If we are to simplify this, you can think of it as an electronic sandwich. In the middle, you have the filling, which is a thin layer of silicon cells that converts light into electricity. This is it. And this filling is assembled, protected, and insulated by polymers and glass sheets. And they are encapsulated within an aluminum frame, as you can see in here. And you have a box that contains everything related to the wiring needed to transport the produced electricity. In terms of materials composition, and as you can see in here, glass is the main component with 80% contributing to 80% of the weight of the panel. You have aluminum, 10%, polymers, which is constituted of different types of plastics, approximately 3% of silicon, copper, and the rest will have minor quantities of silver, tin, and lead. This is the weight composition. The things you see here in yellow, this is the value of these products in terms of money. So although the silver, tin, and lead are the least, they contribute the least to the weight of the panel, but in terms of revenue from selling them, they are the most expensive and the ones that they bring a lot of money. The other type of panels is the thin film-based panel. We can say that they provide a more effective way of producing electricity, but they are less efficient than the first type we talked about. So if you want to produce the same amount of electricity, you would need a bigger area of these panels. And these, in terms of anatomy, they are composed of 3 main layers. So you have also, it's like a sandwich as well. You have in the middle, the main semiconducting material, which is the photovoltaic material that produces electricity. You have then the conductive sheet, which is a layer of conductive material, mostly aluminum, to prevent electricity loss and improve the conductivity. And you have the protective layer, which is a thin layer of high quality glass that is added on top of the system to improve the durability of the system and protect it from the environment. They call these panels thin because they are 300 times to 350 times thinner than the first type we talked about. And in terms of composition, as you can see in here, 86% of this material is glass. Aluminum contributes by 11%. And the rest is in here. These are hazardous material like the cadmium, which is one of the most hazardous heavy metals. So are the panels classified hazardous or not? To answer this question, many countries, before classifying a waste under hazardous or non-hazardous, they do some kind of a test, which they call leaching test. And in this leaching test, they take part of the panel, they dissolve it in some liquid, and then they analyze that liquid for the presence of hazardous material. And usually there are some levels of thresholds. Above a certain threshold, the material will be classified as hazardous. So in most of the tests that have been carried out across the world, these panels, they were not proven to be hazardous, although they include a minor amount of hazardous material. So in many countries around the world, from a regulatory perspective, I'm saying, they fall under general waste. So in many countries, they are allowed to be dumped in a landfill or a dump site. There are no restrictions related to treating them as hazardous waste. In the EU and in some other countries, these are classified under electronic waste. So in the EU, they fall under the Electrical and Electronic Equipment Waste Directive. This is as far as the solar panels are concerned. Now we move to the batteries. Again, there are different types of batteries, as we said, two main types, the lead acid batteries, and under lead acid, we have 3 different types of batteries, but they all share almost the same technology. And the main ingredient in them is lead. There are cons and pros of each. I'm not gonna go through these in details. And we have the lithium ion battery, which is somehow a new technology. The lead acid battery is an old technology that is used in many applications, like in the cars. Lithium ion battery is newer and it's more expensive in terms of the technology and more complex. So if we want to talk about the anatomy of these, as you can see here, the lead acid batteries in terms of physical configuration, they include a casing, which is most of the time made up of plastics. You have the electrolytes made up of lead, the electrolyte solution, which is made of sulfuric acid, and a membrane separator made up of some kind of plastic. And in terms of composition, the bulk of these batteries is lead, 65% by weight lead. And then we have the acids, the plastics, and other components. When it comes to lithium ion battery, again, we have the battery casing, we have the electrolyte, different type of electrolyte, and we have the membrane separator. But as you can see in here, they include a blend of multiple critical elements that could possibly be recovered by recycling. And most of these are hazardous in nature. And as you can see in here, the composition is very clear. Are batteries classified under hazardous waste? Yes. In almost all countries, batteries fall under hazardous waste. In some countries, like in the EU, they have a directive that is specifically dedicated to batteries, how to deal with them, how to manage the waste resulting from them, who is responsible for them, what is the financial scheme used to ensure that there are financial means for recycling these batteries, etc. In the States, there are different regulations. There is one common regulation across all states, which is related to the lithium-ion batteries, and this is these are classified as hazardous. For the lead-acid batteries, it varies from a state to the other. So now let's look at the recycling challenges facing the recycling industry of each of these two components. We're going to start with the panels. So as we said, the anatomy of the panels is a bit complex. And part of the components, as you can see in here, the aluminum frame and the glass, as well as the external copper wires, these are very easily separated using physical means of separation. However, the recovery of the silver, copper, and high purity silicon in the silicon wafer that you can see in here is really requires sophisticated technologies to be able to do that, because these solar cells are encapsulated in layers of this EVA, it stands for ethylene vinyl acetate, and they are sealed and bonded in a way to the glass that makes breaking this bond really difficult and challenging from a technical point of view, and it requires specific and well-dedicated technologies. And the process of doing so is really expensive. It's not a cheap process. And as a result, the cost of recycling is often not justifiable and is not a trigger for whoever is interested in the recycling industry. You know that in the recycling industry, the financial feasibility of the process is a major driving factor, especially when there are no regulatory framework forcing the recycling of such material. So this is mainly the main challenges facing the recycling of the solar panels. And that's why a lot of money is being paid at the moment in research and development programs to come up with treatment or recycling technologies that are cheaper, and at the same time to optimize the manufacturing process of these panels and make them manufactured in a way that facilitates the recycling process later on. So in general, the process of recycling the panels, you have three major steps. In the first step, you remove the metal frame and the terminal box. In the second step, you have to eliminate the encapsulant from the laminated structure. And this is the most challenging activity and the most expensive one. And then you have the recovery of the metals that are within the solar cells. This is a technology that is present worldwide, but it's not something easy for anyone to implement. It is basically, it is based on mainly using chemical extraction for all the metals. So it's something that has to take place in a very controlled environment and in a very specialized facilities. For the batteries, the situation is different. Let's talk first about the lead acid batteries, because this is an old technology that has been present in the market for a long period of time. Because of the high lead content, if you remember, that was 65% by weight, and because of the stable and attractive market prices for lead, the lead acid batteries are recycled all over the world. And the recycling process, as you can see in here, it undergoes a series of steps. So at first you have to break and separate the different components, the plastic cases, the electrolyte, and then you have the other components. And then each one of these components, it undergoes a series of special treatment processes to recover materials that can be sold to the market. This whole process cannot happen in every facility. It has to take place in a very specialized facility in a controlled environment, because when this is done in an uncontrolled environment, most of the time they recover the plastics and the lead and they throw away the sulfuric acid. And this is something that is very damaging to the environment.
Nasreen, I'm sorry if I'm cutting you off, but if we can wrap up this segment in 1 minute.
Yeah, sure.
Because even those details, I think we're going to be covering those details with Elie. So if that's possible, that would be great.
I'm done, actually. This is, I think this is my, the slide before the last slide. Okay. So for the lithium ion battery, this is a new technology. It's still the treatment and the recycling of this type of batteries is still undergoing a lot of research. Only few countries have recycling facilities for this type of batteries. And that's it. I think we can discuss these concluding remarks maybe in the discussion by the end of the webinar. To save time.
For sure. Thanks a lot, Nasreen, for the very informative presentation. And as I told you, now we're going to go more in depth with regards to the processes that have to do with the repurposing and recycling of that particular waste. But first, allow me to introduce our last speaker, last but not least, Elie Romanos. Elie, thank you for being with us again. Elie is an energy specialist at Arc-en-Ciel, where he works on the development of energy projects with a focus on biogas, solar systems, and energy storage technologies. previous experience in project studies and development for refineries and power plants, waste management and waste to energy plants, factory utilities systems design and implementation, and machinery design and manufacturing. Eli graduated in 2008 with a mechanical engineering degree from the Lebanese University. He has a research master's degree in mechanics from the Doctoral School for Science and Technology at the Lebanese University, and a Master of Science degree in Energy Studies from the American University of Beirut. Eli, hello.
Hello, thank you.
Tell us more about how can we dispose of, repurpose, or recycle the waste generated by the PV market. The floor is yours, Eli.
Thank you. Thank you for the invitation. It's a pleasure to be with you. First, please let me introduce Arc-en-Ciel. We are a non-for-profit organization. We are founded in 1985. The mission of Arc-en-Ciel is to support the unprivileged people and to contribute to the sustainable development of the society. Through 6 programs: the agriculture, environment, mobility and health, responsible tourism, social support, youth empowerment, and culture. At the environment program, we are working on a project called REFIT, retrofitting of public buildings through green technologies and processes. It is a project funded by the European Union. We are partners in this project with ICU and Fondation Diane, 2 NGOs. Fondation Diane is a local NGO, and with the University of Genova. The objective of this project is to support the application of renewable energy and energy efficiency technologies that are economically viable for Lebanon, and with a focus on public buildings. In this project, ICU will rehabilitate existing PV systems on public buildings. Fondation Diane will establish a pilot storage facility for batteries. And there the batteries will be tested for second life application. A technical support will be provided by the University of Genova by developing a testing tool for that reason. And also Fondation Diane is supporting small and medium enterprises who are working on second life application for batteries. We as Arc-en-Ciel, we have done an analysis of the current and potential for the future batteries value chain in Lebanon, along with the corresponding study and the legal framework. And we are also collecting the batteries that are replaced in this project, certainly according to the international environmental standards. Concerning the end-of-life management of the batteries and the panels that are replaced or could be replaced in this project are sent as electronic waste to the pilot storage facility at Fondation Diane, and there they are packaged and will be exported to a recycling facility abroad, because there is no solution for them recycling for them here in Lebanon. Concerning the batteries, they are all lead-acid batteries for these projects till now, and for all the projects. We are collecting them, we are storing them and preparing them for exportation to be recycled abroad. We will talk about this issue in a bit. There is a recycling value chain in Lebanon for the lead acid batteries, but it is not compliant with the environmental standards. Now, here are some key data concerning the expected expansion of PV systems in Lebanon. In 2019, we were at 78 megawatt installed. In 2030, we are expecting to reach the 150 megawatt installed according to the National Renewable Energy Action Plan, and up to 500 megawatt installed according to the Renewable Energy Roadmap. Those are decentralized systems, while we have also a big potential for centralized forms. Concerning the batteries, the share of PV project with batteries is expected to increase because of the crisis, the electricity crisis we are facing now. And since this type of systems is more resilient with batteries. Today, in the old projects, we have almost all the batteries installed in PV systems with batteries are lead acid batteries. Although we know that the lithium battery is becoming cost effective, but it is still now limited to new and big projects. But when it comes to choose between lithium and acid battery, we are expecting that the customer or the installer will still be opting for a lead acid battery because it is cheaper as a direct investment. Although I will repeat it, the lithium battery has become more cost effective in the long run. Concerning the projection of ULAB from PV, the ULAB is the used lead acid batteries. In 2020, we were at 450 tons of ULAB. This quantity is expected. Quantity is expected to grow till 2030, according to two scenarios. Those two scenarios, we are assuming those two scenarios. These are a hypothesis. Scenario A, 3% of new project capacity will include batteries each year. And this number is the number of 2019. Those are real projects statistically. And according to this scenario, to scenario A, we will reach in 2030, 1,000 tons of ULAB. And these quantities are calculated based on a 500 megawatt installed in 2030. In scenario B, we assumed a 6% of this percentage because of the electricity crisis. And according to scenario B, we will reach the 1,460 tons of ULAB in 2030. Now, our analysis of the current battery value chain has shown the following diagram. This diagram shows the quantities and flow diagram of the spent batteries. These are average quantities between 2011 and 2019. These quantities are all the batteries quantities from all the sectors in Lebanon, not only from PV systems. As we can see, the biggest quantity of spent batteries are lead acid batteries. They are ranging between 15,000 to 22,000 tons per year. These batteries are collected and they are locally treated here in Lebanon. And the recycled lead is exported, and this is generating revenues for Lebanon. But unfortunately, all this value chain is not compliant with the environmental standards. All other batteries, including the lithium batteries, totaled at 1,300 tons per year. Almost all these batteries are lost in the municipal waste. Only a negligible quantity is collected and exported for recycling abroad. So for the lead acid batteries, we have a big potential for an organized local treatment. While for the lithium batteries and PV panels, there is currently no local treatment. The only option, environmental option, is to export them for recycling. These are some international environmental standards for the ULAB. We can mention the no draining, there must be no draining at collection points, storing in proper places at collection point, electrolyte, the acid must be sent to effluent treatment plant, best available techniques for health and environment protection must be applicable in all the value chain from the collection to the treatment to the disposal. All these standards are not applied, unfortunately, in Lebanon, and this have dangerous consequences on health and environment. For example, the lead recycling from ULAB can reach the water, can reach the soil, can reach the air. The workers in this value chain could transmit this contaminants to their families through their clothes, and this have dangerous consequences on their health. Finally, we had, as I mentioned, we have made a legal study of the Lebanese legislation These are, I will mention some of the gaps that were identified in this study. The classification of hazardous waste and non-hazardous waste. I will go through the titles without entering into the details. The responsibilities in placement of batteries on the market and the management of the waste. Who will be responsible of the management of the waste? The producer who will put the batteries or not. This is not mentioned clearly. The identity of the waste generator, it is a very important point because the waste generator, according to the legislation, will be responsible of the management of waste. The collection and storage and transport. There is no specific responsibility according to the collector. There is no specific technical standards for treatment and final disposal. Among other gaps, we will, at the end of this project, we will communicate all these gaps, the recommendations, and the proposals that are made in this study to the Ministry of Environment through roundtables that will be held between us, the Ministry of our partners, the stakeholders, and the Ministry, in order to reach a better value chain in Lebanon. Thank you. That's it. I would like to apologize for not being so generous in details, but we are planning to publish all the results of the studies at the end of this year, and we will share it with you certainly.
Thanks a lot, Ali. Yes, exactly. For those who are asking for the presentations, regarding the presentation that Ali just showed us, I guess, yeah, we would have to wait for the publishing of the study that they're working on.
And sorry for that. At the end of this year, of course.
For sure, we're going to be looking forward. And before I start the Q&A, please allow me to ask you a question, Eli. Would applying those international standards that you talked about, if we apply them, would the whole process throughout the value chain maintain its profitability? And I'm talking about Lebanon. So if those who are doing the recycling and the repurposing, if they apply those international standards, would it still be profitable and lucrative?
I cannot give a certain answer about this because we didn't study what is the cost of implementing the standards, but the numbers are very high, and we are expecting that the profitability of this value chain will be capped in applying the environmental standards.
Sure. Thank you. So please allow me to start taking some of the questions. So we have a question from an anonymous attendee, actually, and he or she are asking, what is the reliability of solar systems marketed right now in comparison to the cost? And I guess the best speaker to be talking about this is Mark. So Mark, if you could please answer.
Yes, thank you, Ali, and thank you for the question. I read it, yes, and wanted to answer live. So I think, like currently and frankly speaking, what is currently being installed, I mean, what has been installed over the past year, as of October 2021, when the Ministry of Energy and Water and the LCAC new procedure was launched, I think more monitoring and assessment of the equipment is done. But what has been installed before and some of what is currently being installed, we cannot really assess. But what I could say, and like an advice for everyone who is aiming or willing to have a system, is just to ask, get several, let's say, quotations, several companies, ask several well-known companies in the market, in the Lebanese market, and not really go with the first one who tell them that, yes, we need to install, I'll get you, for example, a system at 10 amps, 15 amps, or 20 amps. This is not how it works. And this is like something happening in the market, like everyone now, electricians, etc., with all my respect to everyone, but they are telling some of the citizens or residents who do not have any knowledge in that will give you 20 amps but the quality of the equipment is not really good. So my advice on this is just to ask several companies compare prices, compare qualities and types of equipment installed, and then decide accordingly. The issue is not with the installation, but with the maintenance and the lifetime of those equipment, and this is really key. So I think this is something that awareness should be done on this.
Thank you, and a quick follow-up. I think from the same person. Is it better to wait for government project to produce electricity for solar and distribute to clients? And how much time will that take to implement? So I guess also you're better equipped to answer this.
Like, this is a tough one. I mean, the government did not decide or for people to go on these decentralized systems. So it's the crisis who pushed people, and this is the crisis, especially that the electricity was one of the first sectors to reflect the depth of the crisis. So people has felt it in terms of darkness, and this is where they went into these systems. So we cannot know when and if the government will produce electricity soon. I mean, people have went to those solutions just to avoid darkness and to secure their energy security in terms of electricity supply, lights, main equipment, etc. So the crisis has decided the pace of that and not really the government. And I'm not sure if in the very short term we will be having or waiting for electricity from the government more than what is supplying currently. Like, with no solutions in the near future, the situation will remain the same.
Thank you, Mark. So we have a question from Abbas Shmais. He's asking, do we have any spill kits for lithium batteries in Lebanon, and is it necessary to be installed with the PV system in houses? So I would leave if Nisreen or Ali would like to answer this question.
Personally, I'm not sure whether these kits are existing in Lebanon, but what I know for sure is that the batteries, the way they are manufactured, they are safe to be used in home. And the risk of spills is really small. I don't know, Ali, if you have something to add on this.
No, nothing to add, really.
So let's check what other questions we have. I'm gonna pass on the questions of advising for certain brands because I think we're not gonna go into this. Maybe on a personal, we could connect you with some of our experts here, and they would give you an advice after the webinar. So we have also Firas Shuman, and Firas is asking, why not allowing the market to be part of the solution, i.e. tackle the business environment and safeguard environmental regulations and standards? Example, expired car batteries are being taken once one changes the battery with a price deduction. Another example is paper. Now we see paper recycling manufacturers, glass, aluminum, waste to energy. So why not focus and encourage policy that will provoke private sector to see the opportunity, including incentives to kickstart their business in PV, deep cycled batteries, recycling businesses. Until then, have them exported to countries where they have the recycling facility until it's feasible to do so in Lebanon. So I guess maybe Ali, you could address this question.
Okay, I mean this value chain here in Lebanon, it is advisable to support it. But the only missing point is the environmental issue, and we have always to add the consequences of this problem economically. It will be heavy economically, the health issue, and the environment will have economical issue consequences. When we have to calculate the profitability of any project. So the environment are the only missing point is the environmental issue, and the recommendations of our project will be for the future to encourage and to support this value chain that exists in Lebanon, in this sector and in other sectors, in order to make the profit for the Lebanese people, yeah, but to protect them at the same time.
So I'm also going to take, I'm going to stay with you, Eli, and take another question from Danielle Faris. And Danielle is asking, will Arc-en-Ciel accept taking lead acid batteries from a specific location for recycling?
Currently, we can take it, but we're not in operation now. We are only operating on the project of refit. But in the future, we are planning to be a collector of lead acid batteries.
Sure.
But now we will not be able to take it. And I think next year we'll be ready for this operation.
Sure. Thank you, Eli. And I apologize in advance because we have a lot of questions, and I don't think we're going to be able to cover all of them, but we're going to try to take as much as we can. So we have a question from Maha Shalhoub, and Maha is asking, what are the new techniques in solar that are under study that may afford more cost-effective systems or could require less space than the ones commercially used nowadays? And Nisreen, if you could tell us more, maybe you have something to say about this.
Well, I have something to say from a waste management perspective, but I think she's asking from a solar PV system perspective, and it's not something that is within my field of expertise. Sure. So I don't know what is really new now in terms of PV systems. I'm not sure.
Sure.
In terms of waste management perspective, there are a lot of research at the moment that is undertaken by mainly by the producers of these solar panels, because in many countries in the world, it is their responsibility to take back the waste and recycle it and reuse the material. For instance, in the EU, under the EU directive, it is based on the extended producer responsibility, whereby whoever is producing the material is in charge of collecting back the material by the end of their lifespan to treat them and to recycle them. And this is very important to include in any policy, especially when it comes to systems like the solar panels, whereby the recycling is not economically feasible from a financial point of view. For instance, for the batteries, you don't have this problem. A lot of people from the informal sector are working in the field because it is economically feasible. I hope I covered part of the question.
Yeah, I mean, unless the other speakers have something to say about this, I would move on to the second question.
I have nothing to add.
Sure. Okay, so we have a question by Salah Itani. Would you recommend people installing on-grid or off-grid systems? And though this is a bit far from our discussion, but I guess it wouldn't hurt answering the question. And I guess, Mark.
Frankly, also we cannot say, like, it depends on the final user, depend on the where are we installing and for what purpose. So it really depends on if it is a household, if it is a shop, if it is an industry. It depends on the scale of the installation. So currently, during the crisis, what's currently being installed are off-grid solar plus batteries kits. So they are not sharing anything with the grid currently, because also the process for applying for net metering within EDL is really hard in the current circumstances and taking a lot of time. So unless it is for an industry, for a huge installation, they are not sharing anything with the grid currently.
Sure.
But again, it depends on the purpose of it. What does the client need? So is it for his house, for his shop, or industry, or whatever?
Sure. So I'm going to take just two more questions. Okay. We have a question that I think is relevant and important, also by an anonymous attendee, and he or she are asking, for the PV, is there any way to revive the panel rather than dismantle and recycle? Similar to batteries. So if maybe Nisreen.
Me personally, I don't know if we can.
Actually, I've read something about that. At the moment, the way the panels are manufactured, they are not really manufactured in a way that they can be reused, or if they are damaged, to correct the damage and then reuse them. And this is again something that is under research. This is one of the things that they are doing a lot of research to see how they can further increase the lifespan of these panels. Believe it or not, this problem is really worldwide. It's not really a problem only specific to Lebanon, because now they are starting to see the end of life of many of these, the previously installed PV systems.
Thank you, Nisreen. So I'm going to take one last question, and this is, I think, to you, Eli, also by an anonymous attendee. Also, they are asking, is the recycling facility in Bekaa safe and compliant with the environmental standards? I'm not sure which recycling facility they are referring to. I'm not sure if you have an idea.
There is one recycling in Bekaa that is registered in the ministry, but and we didn't go there to do the study. We are planning to make environmental study on the whole value chain in Lebanon, considering all the yards and the facilities that are doing this recycling. But till now, we didn't find any collector or treating according to the environmental standards.
Can I add something? I'm not sure whether they are working in accordance to the environmental standards, but what I'm sure about is that they are efficient in collecting the batteries from the market. Because when in my company, we're involved in the treatment of waste, and we don't see a lot of batteries within the waste stream that is collected, at least from the major areas in Beirut and Mount Lebanon. So apparently, whoever is recycling that is being very efficient in collecting them from the market.
Thank you, Nisreen. And I guess with this question,
can I just final note on this before? So I'm just one of the questions, and the last one about the pollution or overrated solar equipment or something. So I don't want to and also we are sharing or highlighting or shedding the light on a problem that is coming in few years' time. Of course, we are supporting, and we should always do this transition to solar systems, and not only on a small scale, but also on the national scale. But what we are trying to do or to say is that this might cause a problem in few years' time, and we should be ready for that. Of course, installing currently solar would be better and more environmentally friendly than the diesel we are using for generators. So of course, we push people, encourage people to install this, but on the policy level, and everyone also on this panel, we are raising awareness on some of the problems coming in the future, and we should be ready for that. So it's not at all overrating solar or doing something that's against solar. To the contrary, we are supporting renewables always.
Exactly, Mark.
Sure.
And yourself, we've also had a webinar a few months ago also about renewable energy and solar systems. And yes, we are not being alarmists here. It's just that in Lebanon, we have the habit of waiting until the problem arises, and then we're confronted with a really, tough situation to deal with. What we're trying to do is look ahead of things and try to already establish some regulations maybe, or some practices that would save us another crisis, another waste crisis True. That we're not prepared with. True. So this is the whole point behind this webinar. And with those remarks, Mark, we are going to conclude our webinar for today. I would like to thank all of our speakers, all of the attendees. Special thanks to my colleagues at the Issam Faris Institute of Policy and International Affairs at the AUB, and my colleagues at LCPS. And also big thanks to our interpreter for today, Rana. And with that, I would like to thank you all. Have a good day.
Thank you, everyone. Thank you, Eli. Thank you, Nisreen.
Thank
Bye.
you.